Okay, let's continue with Thevenin and Norton theorem. Okay, so in our discussion last Tuesday, the way we determined the Thevenin resistance was we got the equivalent resistance looking into the terminals of the network with all independent sources reduced to 0. So if you have a network, and then these are your load terminals. So these are your load terminals. Okay. What is the Thevenin resistance? The Thevenin resistance is the resistance looking, so this is RTH, the resistance looking into the load terminals, looking into the terminals with all reduce all independent sources to 0. With all the independent sources reduced to 0. But remember, that will only work if the network has only independent sources. In fact, that's what I put here. No, this will only work if the network contains only independent sources. Kung itong network na to may mga dependent sources, hindi mo magagamit yung technique na yon. So ano yung technique na ginagamit therefore to determine RTH? By the way, this is an example. Okay, this is an example, no? Circuit with only independent sources. So take a note, this circuit has only independent sources. Okay, so let's just do this very quickly, because you should already be able to do this on your own. So find the voltage V sub O using Thevenin's theorem. So if you use Thevenin's theorem, what you do is you remove first the load. So assume that the 1K is the load which you remove. So you remove the load, which is the 1K ohm resistor. Okay. So what do you get? You get the following, no? You get this network. I just redraw it very quickly, no? So tinanggal natin yung 1K. Okay. Okay. So this is 600. This is 300. This is 300. And then this is 500. Okay. So to get RTH, because this consists of only independent sources, walang dependent sources dito, to get RTH, we can use the technique that we discussed earlier. No, what you do, you first reduce all of the independent sources to 0. So when I do that, okay, magiging short circuit yung voltage source. Then you have your 600. You have your 300. You have your 300. Okay, what will happen to the current source? The current source will be an open circuit. So kung open circuit siya, wala na siya, no? So all now you have to do is get R equivalent here, no? Which is equal to RTH. So that's going to be, what's that going to be? That's just going to be 600 in parallel with 300 plus 300. So that's simple enough. Again, no, pwede mo lang gawin yan dahil itong lahat na to are independent sources. Okay, how do you get the Thevenin voltage? The Thevenin voltage is the open circuit voltage across the load terminals. So this is your Thevenin voltage, VTH. No, we'll assume that it has that particular polarity. Okay, the way you get Thevenin voltage, nasa sa inyo na ngayon. Ano? It's up to you, right? The tool that probably you are most familiar with at this point is your nodal analysis method. So you can use nodal analysis. You can make, for example, the bottom terminal ground, and then you can use this as one of your nodes. This will be another node, and you can use nodal analysis. But remember that nodal analysis is useful when you want to compute for many variables in your circuit. In this particular case, we are only computing for VTH. So when you're only computing for VTH, is it possible for you now, lagi niyong iisipin to, no? Is it possible for you now to reduce the remainder of the circuit into a simpler equivalent circuit? And the answer is yes. What can I do? Okay, what can I do? No, for example, tignan lang natin, ano? Tignan lang natin. Remember, what we have to do is we have to preserve the terminals of VTH. Itong 9 volts in series with 600 ohms, I can convert that to a current source using voltage source current source conversion. Right? So if I do that, what am I going to get? Do I have space? Okay. If I do that, what am I going to get? So again, ito yung 9 volts. Ito yung 600, no? 600 ohms. Just draw it very quickly. VTH. Okay. I can convert this to something like this, you know. What is my current source value going to be? It's going to be 9 divided by 600. So I have a current source. Okay, take note that the current should be from the negative to the positive. So this is 9 over 600. And then I now have a 600 ohm resistor. Okay, and that will now be in parallel with this. No? So I'll have my 300 ohm resistor there. Okay, then I'll have this. Okay, what is this? This is also 300. 300 nga ba yan? Yes, 300. Then I have this and this. Okay, ito 500. And then I see that these two now are in parallel. Okay, so what's next? So meron akong current source dito. Pwede ko i-combine ngayon yung dalawang resistor into a single resistor. So this is 600 in parallel with 300. Okay, and then this is 300. Okay, and so forth, no? 500. Note that I have to preserve the terminals of VTH. Ito kailangan ko i-preserve to. No? So make sure that while you're doing your circuit simplification, you don't lose this. Okay, this one, again, I can connect this to, convert this to a voltage source. So ano yung magiging voltage source ko ngayon? Meron akong 300 dito. And then this one now is 600 in parallel with 300, and then I have a voltage source, plus minus. So this is now VTH. Okay. Ano yung value ng current source? 10 mA, no? This is 10 mA. and this is 500. Okay, see how much simpler the circuit is now? It's much simpler, and so forth. Anyway, I'm not going to complete the solution anymore. No, what we're trying to do is get the value of VTH. So madami kang options ngayon. No? Now you know the current flowing here. You know the current flowing here because that is dictated by this 10 mA source. Okay, you know this voltage. This voltage is from the voltage interconversion, and so forth. You know all the resistances, so you should be able to get the voltages across these two. No, you should be able to get the voltage across these two. Then you can do a KVL, for example, here. Anyway, this will allow you to get VTH. No, that will allow you to compute for VTH. So I won't go through the details anymore. Okay? So you can try this at home as an exercise. So again, I'm suggesting this as an option to nodal analysis because you can also compute for VTH using nodal analysis. Any questions with regard to this example? Okay. Now, try the example also using Norton's theorem. So kung Norton's theorem naman, ano yung gagawin natin? Tatanggalin natin yung load. And then we'll get the Norton current, no? Yung Norton resistance, alam na natin, that's the same as the Thevenin resistance. So you take out the load, you replace it with a short circuit, and then you get the Norton current that is flowing. Anyway, at the end, no, we're supposed to determine V sub O. Kapag nakuha na natin yung either Thevenin equivalent or your Norton equivalent, isosoli lang natin yung load, which is the 1K. And then that will allow you to determine the value of V sub O. So again, just try that on your own. Okay, so this is where I was headed for after my first slide. What if the network contains both independent and dependent sources? Ano yung method for determining RTH? Yung method for determining VTH, that will be the same. There's nothing that will differentiate this from the other problems that we've discussed so far. It's really the method of determining RTH which will change. So ganun pa rin, you remove the load, yun yung unang gagawin mo. Then you determine the open circuit voltage, that is the voltage across the load terminals with the load removed. And note that that open circuit voltage is actually your Thevenin voltage. Okay, next you connect a short circuit between the load terminals, and then you'll get that short circuit current. And note that the short circuit current will also be equal to your Norton current. Finally, RTH is the ratio of your open circuit voltage and your short circuit current. Or RTH is also the ratio of your Thevenin voltage to your Thevenin current. So let's take an example. Okay. The problem is find the current IX using Norton's theorem. Using Norton's theorem. So ano yung first step dito? We want to find the current IX. We consider the 125 ohm resistor to be the load. So we take it out. So what is our circuit? Our circuit will be like this. This is Vx over 400 ohms. 300 ohms. Okay, we have 10 volts. 100 ohms. $200 ohms. Andito yung Vx. Right? This is a voltage controlled current source. The voltage that controls this current source is this Vx. So ito tinanggal na natin yung load, no? Okay, I'm supposed to use Norton's theorem. So I'm supposed to get the short circuit current that will flow here. No? This is I short circuit, which is also equal to my Norton current. Okay. So how do you determine now this short circuit current? Well, you have a lot of tools already in your arsenal for you to be able to do this. No? But anyway, let's take a look at this circuit. If this is a short circuit, ano ang magiging value ng V of X? Can someone shout it out? Okay. If this is a short circuit, what will be the value of V of X? Anyone? Are you guys awake?
0.
Okay, may matapang si Mark Anthony, 0. Okay, of course 0, no? The voltage across a short circuit is equal to 0. Therefore, V of X, if V of X is equal to 0, ano magiging value nitong current na to? Magiging 0 rin. In effect, parang open circuit ngayon to. Right? This thing is an open circuit because the current that will flow here is 0. So V of X is equal to 0. Therefore, Vx over 400 is equal to 0. So in effect, this is an open circuit. No? Ito, open circuit. Okay, kung open circuit yan, ano na lang yung matitira nating network? Ang matitira na lang nating network, okay, andito yung 300. Andito yung 10 volts. Andito yung 100 ohms. Tapos yung short natin. Okay. This is now our ISC. Okay. Tanong, bakit hindi ko kailangan ilagay itong 200 ohms? Remember what I discussed before? If you have a short circuit across any resistor, no current will flow through that resistor. All the current will flow through the short circuit. In effect, this will since no current will flow through this resistor, you can remove it. You can remove it. Wala namang kasing current na dadaan dyan. Lahat ng current dadaan dun sa short circuit. So kita-kita dito, madali na natin makukompute yung ISC. Right? You can compute for ISC. What is ISC? ISC is just equal to 10 over 300 plus 100. No? Plus 100. So that's 10 over 400. Oh, 1 over 40. No? So this is yeah, 1 over 40 amperes. Did everybody see that? Okay. Did everybody see that? Any questions? Okay. Remember that hindi ko pwedeng gamitin yung technique for getting RTH dito dahil meron akong dependent source, no? Hindi ko pwedeng yung technique na ginamit natin dati na you get the equivalent resistance with respect to the load terminals, reducing all independent sources to 0. Hindi pwedeng gamitin yon because of this dependent source. So for me to get RTH, I have to compute also for my Thevenin voltage. Okay, how will I compute for my Thevenin voltage? So I have, okay, Vx over Vx over 400. Okay, that's a current source. 400. Yeah. This is 300. This is 100. Dx, the total is 200. So this is my Thevenin voltage. Now this is my open circuit voltage, which is equal to my Thevenin voltage. But this is 10 volts. That's 10 volts. So how do I compute for my Thevenin voltage? By the way, this is also equal to V sub x. If you take a look, my open circuit voltage is equal to my Thevenin voltage is equal to V sub x. Open circuit voltage is the Thevenin voltage is equal to V sub x. So how do I compute for V sub x? Again, you have plenty options here. But I guess the first option that you probably will think of would be nodal analysis. Pwede, no? Pwede mag-nodal analysis dito. Okay. Pag nag-nodal analysis rito, ang suggestion ko, ito gawin yung ground. Okay. What is this voltage? This voltage is V sub x, right? Because if the negative of V sub x is at ground, then the node voltage here is V sub x. Let me call this V sub y. V sub y. Okay, I'm going to have to know the voltage at this point. No? What is the voltage at this point? The voltage at this point is V sub y plus 10. Right? In other words, if this is V sub z, if that's V sub z minus V sub y is equal to 10. Right? So V sub z will be V sub y plus 10. Okay, so applying KCL here, applying KCL there, ano yung magiging equation ko? That's Vx over 200, okay, plus Vx minus V sub y plus 10 over 100 is equal to 0. Right? That's the KCL equation here. Okay, question. Pwede ba ako mag-KCL dito? Can I hear an answer? I think people are not alert
Yes,
this
sir.
afternoon.
Yes, sir. Yes, sir. Pwede,
Ano?
sir.
Ano yung sagot?
Pwede po. Pwede po. Pwede
Pwede?
po. Pwede po.
Wala ka ba nakikita ng problema pag nag-KCL ako dyan?
Sir, floating voltage source. Sir.
Does anybody see any problem with me doing a KCL here? Nakalimutan na nyo yung
independent source po, sir.
Independent source. I know the current flowing, ano? So I can get the flowing. Nakalimutan na nyo, no? This is a voltage source. So anong problema pag may voltage source tayo, nagki-KCL tayo? Hindi natin alam kung ano yung current dyan sa voltage source na yon, remember? So anong ginagawa natin when we have a floating voltage source? In effect, this is a floating voltage source. Anong ginagawa natin?
Sir, supernode.
Yeah, that's right. No? Kailangan mo ng supernode. Okay? So, sorry. So this one is a supernode. So what is the equation for your supernode? Okay, so I have a current here entering. Ang current dyan na pumapasok, that's negative, so minus Vx over 400. I have a current here going down, so that's Vy over 300. Okay, remember this is Vy. I have a current here that is leaving. What is that current? That current is Vy plus 10 minus Vx. Remember, this is, let's say, V of z, but V of z is Vy plus 10. So Vy plus 10 minus Vx all over 100. And this is equal to 0. So I have two equations, two unknowns. This is one equation. And then this is another equation. I should be able to solve for V of x. Yeah. Trying to see whether I have the solution. Okay, anyway, so you solve these two simultaneously. Okay, pag nagawa niyo yun, okay, I don't have the actual number, no? I thought I wrote it down somewhere. Dali, no? Yeah, I'm sorry, no? I thought I wrote it down earlier when I solved this problem, but I don't have the actual number. But the point is this, no? So pag nakuha na nyo yung V of x, no? After solving for V of x, which is equal to VTH, no? Then my RTH, which is equal to R of n, which is also equal to my Norton resistance, that is just equal to VTH over I of n. That's equal to VTH over I of n. So I'm going to get now my Norton equivalent. My Norton equivalent, I will have I of n and then R of n. And then all I have to do is reconnect the load. All I have to do is now reconnect the load. Okay. So dito ikakabit ko uli yung 125. Okay. So pag alam ko na to, how do I now compute for I of x? Can someone tell me what I can use to compute for I of x?
Current division. Sir.
Yeah, current division. No? So now you can use current division. So again, I just leave it up to you to complete the solution. No? Pinakita ko na sa inyo how you're supposed to do it. Ang key, again, let's go back. No? Ang key is, since my network contains both independent and dependent sources, then I have to get the open circuit voltage, the short circuit current, and then RTH is the ratio of VOC over ISC. That's how I compute my Thevenin resistance. Okay. What if the network contains only dependent sources? So again, this is another method for determining RTH. So what is the procedure? Again, you remove the load. Don't bother with number 2 first, ano? Kasi sinabi na nga ritong dependent sources lang, ano? So dapat kung dependent sources lang, walang independent sources. So actually, kaya nakapula yung number 2, no? Because presumably, we will use this method only when there are no dependent sources. So parang number 2 is actually not applicable. So you remove the load. And then you connect a test voltage. Usually we set this to 1 volt. No? This is just to simplify the computation. We connect the test voltage to the load terminals. And then we determine the current that will flow through the test voltage. And RTH is the ratio of your test voltage to your test current. By the way, instead of test voltage, you can also use a test current, and you determine now the voltage that the test current will supply. Okay, why did I put this red here? Actually, this method, itong method 3, can be used all the time. It can be used if your network contains only dependent sources. It can be used if your network contains both dependent and independent sources. But it is the only method available if your network contains only dependent sources. So itong method na to can be used all the time. Kaya pinasok ko tong pula dito, no? If you're going to use this method for the other types of networks that we discussed, you're going to have to perform step number 2, zero out all independent sources. Okay, so here's my example. Find the Thevenin resistance as seen from XY. So dito, okay, kita nyo that there are no independent sources. Walang independent source dito. All I have is a dependent source. So kung ganon, kung walang independent source dito, what do you think will be the voltage across X and Y? Anyone? There is no independent source. It's only a dependent source. What do you think would be the voltage across X and Y? Can anybody guess?
Zero, sir. Zero, sir.
Kumbaga wala akong source, no? Wala akong source of energy dun sa circuit ko. I have no source of energy. This is a source of energy only if there's a value of I of X that flows. But I of X has to be created by something. I don't have a voltage source here. I don't have a current source here. So automatically, when you see a circuit like this, the open circuit voltage or the short circuit current will always be equal to 0. No? So for cases like this, dependent sources only, your open circuit voltage will be equal to 0, and your short circuit current will be equal to 0. So ano ibig sabihin nito? No? VTH is equal to 0, IN is equal to 0. So ang problema lang natin is what is RTH? So in effect, this thing, we should be able to represent by a single resistor. So how do I solve this problem? Okay, so two ways. One is I can connect a test voltage. Okay, I can connect a test voltage across the terminals and then determine the test current. No? So ito yung technique. No? Maglalagay ako dito ng voltage source. Let me call this V of t. And expectedly, there will be a current I of t that will flow. RTH will be equal to V of t over I of t. Because RTH has to follow Ohm's law. Now, if this is equivalent to a single resistor RTH, then that has to follow Ohm's law. That should be V of t over I of t. Para maging madali buhay natin, so for convenience, let V of t is equal to 1 volt. This is just to simplify life. Remember, this is the test voltage, so I can choose any test voltage I want. So let V of t equal to 1 volt. Okay. So that means if this is my reference node, the voltage at this point will be 1 volt. Okay. So how do I solve for I of t? Okay. What is this again? This is a floating voltage source, right? Floating voltage source. So in effect, this is a supernode. This is a supernode. Let me call this node voltage V of x. Let me call that V of x. So what is my supernode equation? Okay, my supernode equation will be V of x over 20. That's this current. Okay, plus V of x over 40. That's this current. Okay, plus 1 volt over 20. So ito yun, 1 volt over 20. Okay, I don't know my current here, no, but that's actually what I want to find. So this is minus I of t. That should be equal to 0. I don't know this current, but yun yung hinahanap ko. So let me define that as a variable, and that's equal now to 0. Okay, what is my other equation? Remember, I only have one supernode in this particular circuit, so I can only form one KCL equation. But what's my other equation? Just to review you. Okay, that's right, no? V of x minus 1 is equal to 20 times I of x. That's from John Edric, no? So the other equation is V of x minus 1 is equal to 20 I of x. But what is I of x? I of x, the current flowing down here, this is 20 times. What is I of x? I of x is V of x over 40. Right? In fact, dito pa lang, makukuha ko na yung value ng V of x. No? I only have one unknown here. Right? So this is V of x minus 1 is equal to 1/2 V of x. So this is 1/2 V of x is equal to 1, or V of x is equal to, tama ba? Yeah, 2 volts. No? So if I plug this v of x now up here, what am I going to get? I'm going to get I of t is equal to 0.2 amperes. So finally, RTH is just V of t over I of t. V of t is 1 volt. Remember, we said let V of t equal to 1 volt. I of t is 0.2 amperes. So I'm going to get 5 ohms. Okay, I want you to try something on your own. Instead of putting a test voltage, put a test current. So imbis na tong test voltage na to, ang ilagay nyo is a test current, no? So you can put a test current I of t. Sabihin natin, you can assign any value to I of t. And what you now end up computing is the voltage across your test current. So if you try that, you should get exactly the same value. If you get V of t over I of t, you should get the same value. So that's what I was trying to say here. No? Instead of a test voltage, you can use a test current. No? And what you try to do is determine the voltage test current will supply. And it's the same. Your RTH is the ratio of test voltage to test current. So I seem to have a question. Okay, no, wala naman. So anyway, these are the 3 methods that we discussed for determining RTH. The easiest method is method 1. This is getting the equivalent resistance, looking into the load terminals with all of the sources suppressed. But this will only work if your network has independent sources. The next method, which you took up, method 2, this will work when the network has both independent and dependent sources. So you get the short circuit, you get the ratio of the open circuit voltage and the short circuit current. That will also work, by the way, for this case. And then the last method that we took up, itong method 3, it will work all the time. No? But that is the only method you have available when your network has dependent sources only. Any question with regard to finding RTH? Yeah, I'm going to take up a very important concept with you, and this is the idea of maximum power transfer, the maximum power transfer theorem. Simply stated, maximum power is delivered to a load R, okay, assuming the load is a resistor, if R is equal to the Thevenin resistance seen at the terminals of R. Okay. So if I have a network, okay, and then I have a load R connected, is equal to my load. When is maximum power delivered to my load? Maximum power is delivered to this load, no, if R is equal to RTH. That is, if I represent the network with its Thevenin equivalent, okay, so this is my network. Maximum power will be delivered to R if R is equal to RTH. And this is easy to see. No? What is the current that will flow here? I. I is equal to VTH over R plus RTH. Okay. The power delivered to R piece of R is equal to I squared times R. So this is VTH over R plus RTH squared multiplied by R. If R is equal to 0, what is the power delivered? It is equal to 0. No? On the other hand, if R is equal to infinity, ano bang ibig sabihin ng R equal to infinity? Ang R equal to infinity, ibig sabihin, walang load. No? Because an infinite resistance is an open circuit. So if R is equal to 0, you see that the power is equal to 0. No? If R equal to 0, piece of R is equal to 0. If R is equal to infinity, this is an open circuit. Okay, piece of R is also equal to 0. No? Imagine that this is infinity. So VTH over infinity will be equal to 0. Okay, so the limit of piece of R as R approaches infinity will also be equal to 0. So if I try to plot piece of R versus R, it looks something like this, no? It will go up and then it will tend to go down again. So there's a point where it's maximum. This is your maximum power. And that happens when this value is RTH. You're taking up now calculus. What you can do is you can try to get the derivative of piece of R with respect to R, equate that to 0. And you're going to find that that happens when R is equal to RTH. Okay. I wanted to, let me add this slide. No? Sandali lang. Okay, so what's the significance of this? No, example na lang muna, no? Example. Sorry. Okay. So let's say this is 500 ohms. This is R. Okay. This is a very trivial example. No? What is the maximum power that can be delivered to a resistance R? So this is the Thevenin equivalent. Let's say this is your Thevenin equivalent. So there's a load connected. So the problem is, what is the maximum power that can be delivered to a resistance R? So how do you solve that? No. First of all, that happens. Yeah, that happens when R is equal to RTH. So meron nang sumubok sumagot. No? That happens when R is equal to 500 ohms. Okay. So what will be the current when R is equal to 500 ohms? I will be equal to 8 volts over 500 plus 500. So 8 volts over 5,000, that's going to be equal to 8 MA. 8 volts over 1,000 is 8 MA. So what is piece of R? Piece of R is equal to 8 MA squared multiplied by 500. Okay. So that's 8 times 10 to the minus 3 squared multiplied by 500. Unfortunately, it's the answer that you provided, I think, is not right. 64 times 0.5. Yeah, the answer is going to be 32 milliwatts. 32 milliwatts. Okay? Okay, anong significance nito, no? And I see people making this mistake all the time, no? For example, if this is a audio amplifier, that's an audio amplifier. And what do you want to connect to your audio amplifier? You want to connect a speaker. If you want maximum power to be delivered to this speaker, the resistance of the speaker should be equal to the Thevenin equivalent resistance of the audio amplifier. Okay, so this, you say the speaker has to be matched to the amplifier. Okay, so kung yung speaker mo is an 8 ohm speaker, then dapat yung Thevenin, kung yung audio amplifier mo has a Thevenin resistance of 8 ohms, then your speaker should be an 8 ohm speaker. Okay, pag nagtabit ka dito ng headset, earphones, for example, don't expect your earphones to pick up as good quality as sound as your speaker, because they are mismatched. No? Mataas yung resistance nung headset natin, no? Nung headset, mataas yung resistance. In the same way, if you just connect a speaker to the headset output of your computer, for example, don't expect the speaker to be able to produce any good amount of music, because again, the speaker is not matched to the headset output of your computer. So this is what you call impedance matching or resistance matching, and that happens a lot of times. No? For example, your cable TV, I think that's 75 ohms. The output, the input, the output resistance of your digibox is 75 ohms. So that means that that the input resistance of your TV should also be 75 ohms. That is, the resistance looking into your TV should also be 75 ohms. No? So you can connect your digibox directly to your TV. But if you try to connect your TV, two TVs to your digibox, so your two TVs will be in parallel now, you only have one digibox, it is no longer matched. Because when you have two TVs in parallel, the resistance will no longer be the same. It will be 1/2. No? Assuming that they're exactly the same TV, you put them in parallel 1/2. So your digibox will no longer be delivering maximum power to your TVs. That's why you have to use the splitter, yung tinatawag nilang splitter. So there are many applications of this. Applications of this in electronics, and even in transmission lines, even in communications. You're going to see this in the future when you start taking up your technology courses. Okay, I have one more topic which I'm supposed to, so let me hurry up. I'm supposed to discuss one more topic with you, and this is superposition. Are there any questions with regard to what we've discussed so far? Okay, so let me go ahead with superposition. I'll try to finish this quickly. This is not that difficult to understand. Principle of superposition. In a linear electric circuit containing n independent sources, the current or voltage in any branch is equal to the algebraic sum of n components, each of which is due to each independent source acting alone. It sounds intimidating when you hear it first, you know? But the concept is very simple. If I have n independent sources in my circuit, okay, let's say I have n independent sources. N independent sources. No? So this contains n independent sources. And I have, let's say, a resistor here. Okay, let's call this I of R. Okay. I of R will be equal to I of 1 plus I of 2 plus I of 3 plus I of n, where this is the current due to source 1 acting alone. No? This is due to source 2 acting alone, and so forth. No? This is source n acting alone. So yun yung ibig sabihin ng superposition. No? If I have n independent sources, then the current or voltage in any branch of the circuit is equal to the algebraic sum of the n components, each of which is due to each independent source acting alone. Okay. Now, how do I make an independent source act alone? To make an independent source act alone, I reduce all other sources to 0, and we've already took this up. How do you reduce a source to 0? For a voltage source, you remove the source, replace it with a short circuit. For a current source, you remove the source, replace it with an open circuit. So let's take some examples. Okay, find I1 and I2 using nodal analysis. So hindi pa ito superposition, no? Using nodal analysis. So dapat expert na kayo rito. So let's just go through this very quickly. Okay, so we apply KCL here at this particular node. So there's something wrong with the, I don't know. So what is my KCL equation? I of S is equal to Vx minus Vs over R1 plus Vx over R2. Okay. So I can simplify this. That is Vx multiplied by 1 over R1 plus 1 over R2. Let's see. Sorry. Minus RS, I think, no? Yeah. Minus RIS is equal to Vs over R1. Okay. So I'll get Vx equal to something like that. Sorry, no, there's a problem with my PowerPoint in my iPad. No, it's not displaying the equations properly. Okay, let's just move. Let's just move to the solution using superposition. Anyway, just do that as an exercise. Determine I1 and I2 using nodal analysis. So I leave that to you. Do that as an exercise. No. So let's try to solve this problem using superposition. Okay, so if you assume that Vs is acting alone, asan yung Vs natin dito, no? So Vs acting alone. So what I would do is I would reduce I of S to 0. So I of S was here reduced to 0. So replace that with an open circuit. It's very easy now to get I1A, which is equal to I2A. And that is just equal to V of S over R1 plus R2. Okay. This current will be equal to this current. No? If now I assume that I of S is acting alone, so I of S is acting alone, so this time I replace my V of S with a short circuit, I can get I1B and I2B using current division. So using current division, okay, I2B is equal to IS multiplied by R1 over R1 plus R2. And I1B is negative. Okay, bakit negative? Because of the direction of the current I1B, no? It's opposite the direction of I of S, no? Dapat yung I of S will divide, I of S is supposed to divide here and here. So negative I of S R2 over R1 plus R2. Okay, so finally, I'm going to get I1 should be equal to I1A plus I1B, and I2 is equal to I2A plus I2B. Okay. So if you feed in these values, this one and this one, and you work it out, you should get exactly the same results as earlier, no? That's the thing I told you to work out on your own. Okay, here's another problem. No? Find all currents using superposition. So here I have three sources. I have an 81 volt source, I have a 9 ampere source, and I have a 6 ampere source. So we have three independent sources. Solve for the currents with each source acting alone. So meaning to say, any voltage or current in my circuit will have three components, one due to the 81 volt source, one due to the 9 ampere source, and one due to the 6 ampere source. No? So with the 81 volt source acting alone, it's very easy to get I of A. No? I of A is just 81 over the summation of all these resistances, 6 plus 12 plus 3 plus 6. With the 9 ampere source acting alone, okay, I can now get IB and IC. Okay, IB, for example, using current division, IB will be equal to 9 multiplied by 12 plus 3 all over 12 plus 3 plus 6 plus 6. Okay. And IC, I can also use current division, or I can use KCL. Let's say we use current division. This is equal to 9 times 6 plus 6 over 12 plus 3 plus 6 plus 6. So nakuha na natin yung currents in all resistances due to the 81 volt source acting alone. Nakuha na natin yung currents in all resistances due to the 9 ampere source acting alone. So let me now get the current in all resistances due to the 6 ampere source acting alone. No? Let's call that ID and IE. So again, you can use current division. So ID is equal to 6 multiplied by 3 plus 6 over 6 plus 12. And IE is equal to 6 multiplied by 6 plus 12 over, this is 6 plus 3 plus 6, no? Plus 3 plus 6. This is 6 plus 12 over 6 plus 12 plus 3 plus 6. Okay. So I now have all of the voltages and currents in each of the resistors due to each source. So for example, if I wanted to get the current in the 3 ohm resistor, I in the 3 ohm, that would be equal to IA plus IB plus IE. No? So that will be this. Okay. So that's superposition. Okay, so the remaining slides just show more examples. So this is an example where you have a controlled source. This is an example where you have a controlled source. So use superposition to find the current I. Okay, remember that it is the sum of the current components of each independent source acting alone. Independent source acting alone. So in this case, we only have 2 independent sources, the 4 volt source and the 2 ampere source. This is not, the 5Vx is not, this is not independent. No? So this will have only 2 components. One due to the 4 volt and one due to the 2 ampere source. Okay, so the 4 volt source acting alone, so magiging open circuit to. So what will I get? I just have 2 ohms, 4 volts, 3 ohms, 5 Vx, where this is Vx. Okay. So I due to the 4 volt source. This is I due to the 4 volt source. How do I compute that? I can just do a KVL here. Right? So what is this? This is I 4 volts times 2 negative, okay, plus 4 plus I 4 volts times 3 plus 5Vx is equal to 0. No? This is KVL. No? It's just KVL. Okay, but what is Vx? Itong Vx na to, Vx is negative I 4 volts times 2. Vx is equal to negative I 4 volts times 2 ohms. So you can solve for I 4 volts. No? It's only one equation in one unknown. Sorry. Okay. Then you can consider the 2 ampere source acting alone. Okay. So this is now ang tawag pala nito is IA and IB, no? I used I 4 volts. So it should be IA, no? IA and IB. But anyway, let's say I 2 amperes. There's nothing I 2 amperes siya. No? Okay, so if this is acting alone, what we did was we shorted out the 4 volt. No? Okay, what you can do is you can do KCL here. Right? Where this is, if this is your reference, this is equal to V of X. So you have V of X over 2, okay, minus 2 plus V of X minus 5 V of X over 3. This is equal to 0. No, this is just nodal analysis at this point. Okay, so you can solve for V of X. Okay, and so what is your 2 ampere source acting alone? That's just V of X minus 5 V of X over 3. So finally, I is just equal to I 3 volts plus I 2 amperes. Superposition. Okay, I'll try to fix up the slides so that so that the errors of PowerPoint are not shown. No? In fact, it shouldn't show. No? So the rest of the slides are just additional exercise. I leave it up to you. We don't have any more time. If we had time, I would have done more of them. No? So sorry. The one I want you to try out is actually this. No, this itong last one. No, there are 2 controlled sources. Okay, you're supposed to use superposition to determine the value of E sub O. Okay, you can try this out on your own. No? If you have a solution and you want me to check it, just send me your solution, and I'm going to comment whether it's correct or wrong. So that's all I have for today. I'm sorry I went over time. No? There was just too much to cover. Are there any questions? Okay, I think you have a lot to chew today, no? You have a lot to absorb. So medyo siguro, no? It went a little bit fast today. There's a lot of material that was published in UVLE. You can take a look at those resources. There are recorded lectures. There are YouTube videos that you can look at. So that's all in UVLE. So I guess that's it. No? So see you again virtually next Tuesday. Okay, thank you.